right? So in today's class, we are going to study about a serializable schedule. So whenever there is some conflict, conflicts can be resolved by serializing the schedules. So you all know that when the transactions are executed serially, one after another, it results in consistent state of a database, right? So the topic for today is a serializable schedule. So we can ensure consistency of the database under concurrent execution by making sure that any schedule that is executed has the same effect as the schedule that would have occurred without any concurrent execution, right? So that is schedule should in some sense be equivalent to a serial schedule. So such schedules are called as serializable schedules, right? So whenever you want to avoid some conflicts, you are going to execute the schedules serially one after another. So such schedules are called as serializable schedules, right? So in the case of serializability, we will not consider the various operations that a transaction can perform on a data item, but we consider only two operations. So we are going to focus only on two operations: read operation and write operation. So we assume that between a read of Q instruction and a write of Q instruction on a data item capital Q, a transaction may perform any arbitrary sequence of operations on the copy of the data item Q residing in the local buffer of the transaction, right? So the point is that to avoid conflicts in execution of an instruction, we are going to go for serializability whenever there is conflicts. So you need not consider all the instructions to resolve the conflicts. We are going to focus only on read of Q instruction and write of Q instruction. A transaction may perform any arbitrary sequence of operations on the copy of the data item Q, right? But we'll be focusing on only the significant operations, namely read of data item operation and write of data item operations, right? So to start with, let us consider a schedule S in which there are two consecutive instructions I and J of transactions Ti and Tj respectively, right? So you have a schedule like what we have discussed long back. So you have two instructions I and J of transactions Ti and Tj respectively, right? So if I and J refer to the different data items, then we can swap I and J without affecting the results of any instruction in the schedule. However, if I and J refer to the same data item Q, then the order of two steps may matter, right? So you have two transactions Ti and Tj. If they are going to refer to different data items, we can swap the execution of the instructions without affecting the results in the schedule. However, if the instructions I and J they refer to the same data item Q, then the order of the two steps may matter.